Hello and welcome back. In the next few videos, I want to be discussing the relationship between heat and temperature. However, in this first video, I just want to focus on temperature. So temperature is one of these things that everybody has a pretty intuitive understanding of. So everybody knows what it means for a temperature to increase or to decrease, and everybody knows what a low temperature is, what a higher temperature is. However, the actual scientific definition of temperature is something that was developed rather recently in the late 1800s. And it turns out that temperature is actually defined as a measure of an object's tendency to give or receive heat. So what this means is that heat always flows from an object with a higher temperature to an object with a lower temperature. And the rate that heat travels from one object to another is related to the difference in the temperatures of the two objects. Now, just like any other quantity, there are a lot of different units that we can measure temperature in. So here I list 3 different units. There's the Fahrenheit temperature, and this is what we use here in the US. There's a Celsius scale, and this is what's used pretty much everywhere else in the world. And then there's the Kelvin scale, and this is the SI unit for temperature. And over here on the left, I list several different phenomena. So there's absolute zero. I'll talk about what that is in just a little bit. There's a temperature where water freezes, and the temperature where water boils. So in the Fahrenheit scale, we see that water freezes at 32 degrees Fahrenheit. And it boils at 212 degrees Fahrenheit. The Celsius scale is set up so that water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. And the Kelvin scale is set up so that 0 Kelvin corresponds with this thing that's called absolute zero. So unlike a lot of other types of quantities, like mass or length and time, there's no real obvious decision for what it means to have zero temperature. So you might say, well, the coldest day that is on record, we could call that zero temperature. But of course, someday later there might be an even colder temperature. And this is kind of how scientists felt about temperature. It didn't matter what temperature you called zero temperature. There was always a temperature that was even colder than that. However, in the beginning of the 1800s, chemists began studying gases, and they were looking at this thing called ideal gases. And when they were studying this, they found that there was actually a lowest possible temperature that they dubbed absolute zero. So the Kelvin temperature scale was set up so that 0 Kelvin corresponds with this lowest possible temperature that's called absolute zero. And because the Celsius temperature scale was already in use at this time, they set it up so that 1 degree Kelvin change in temperature corresponded to a 1 degree Celsius change in temperature. Now, because Kelvin measures a temperature above this absolute zero, this lowest possible temperature, the Kelvin temperature scale is sometimes referred to as an absolute temperature. Now, an important thing to keep in mind when we start looking at equations is that anytime you see a formula that depends on temperature, just T alone, this means the formula depends on the absolute temperature, and you must use Kelvin when you're evaluating a formula that has T in it. However, anytime you're working with a formula that just depends on the change in the temperature, you can use either Kelvin or Celsius. And it doesn't matter which one you choose because a 1 degree Celsius change in temperature is equal to a 1 Kelvin change in temperature. So at this point, I think I'd like to end this video. And in the next video, I'll be talking about thermal expansion.